Hello, and welcome to the December 13th edition of the Cluster API breakout meeting for SIG Cluster Lifecycle. Today is the first meeting we've had after Kubecon, where there was lots of interest in the Cluster API. So I'm hoping we have some new folks on the line. If you are new, please add your name to the agenda doc that I linked in chat and any topics that you'd like to discuss. While you're doing so, I think Jessica had some thoughts about status of provider configs. Maybe we can use that to kick off today's discussion. Except she's muted. Jessica. All right, well, maybe she's not there. Does anybody else have a topic that they'd like to start the meeting with? Silence.
I have a question which you and Chris may have bantered about, is the resolution between the cluster API and some of the work that has gone on in Kubecon and what the plan was there. If Kubecon was just going to leverage the cluster API over time. Yeah, that's what I figured.
Yeah. So I think Chris was working diligently last week to try and get Kubecon using the cluster API before our demo at KubeCon, and it didn't quite work due to some shenanigans with GoDeps. But yeah, she's sort of rebasing Kubecon to sit on top of kubeadmin and use the cluster API. We talked a little bit with the Lutzi guys actually about the sort of proliferation of installers and what we might want to do to reduce that. And I think there's a tension between having sort of like the one true way to install Kubernetes and then allowing everybody to be opinionated. And I know that when I've talked to Justin Santa Barbara, he said that he would prefer if there was sort of one installer, right? If there was one community supported installer and we can make it flexible enough that it would support different use cases, that would be sort of easier for us as a SIG and a community to support and to get behind. I think we've also seen over the last couple of years that I'm not sure we can agree on one mechanism for installation, and people have just sort of built lots of different installers. It's possible that's just because there wasn't one sort of blessed installer, and it's also possible because if someone really likes Ansible or really likes Puppet or really likes Chef, they're gonna follow Kelsey's doc or look through this getting started from scratch doc and figure out how to install a cluster. So I think we should, as a community, sort of aim to support a small number of installers and try to consolidate our support behind a couple that work well. But I think it's a little bit TBD what those might be and how soon we can get there. I think in the meantime, there's still going to be a large number of installers, and we're hoping to move them towards using common tools like kubeadmin and the cluster API. Rodrigo points out that we got some feedback on the cluster API at KubeCon. One sort of minor thing that Bowie mentioned from the networking team is that our description of cluster address ranges, like the cluster network stuff, is not flexible enough. In the future, SIG Network is planning on allowing multiple non-contiguous CIDR ranges for things like pods and services. So we need to make sure we restructure the network configs to take that into account. Rodrigo, I think I saw you on the line. Was there other specific things that you remember hearing feedback about that we should bring up?
We talked about the multiple controllers, machine controllers. Can you elaborate a little bit on that? I think you have more details.
Yeah, so one of well, I guess there were a couple of things that came out of a conversation we had with the Lucy guys. So one is that from their point of view, they would like to use the Machines API to manage nodes but not masters, which in some ways is similar to the GK use case where nodes are visible to users and under users' control, and masters are hidden. And I think that's perfectly achievable with the cluster API as it's written today. If you try to create a machine definition and mark it as a role type master, then the machine controller that's running in that particular cluster would just reject that with an error message. So I think that's okay. The other interesting sort of side conversation we had was about multiple controllers. And so you could imagine a cluster where you have, one controller that is, just like a generic Terraform controller that's able to spin up, Terraform machines, and another controller that's maybe a specific AWS controller that's able to spin up machines using an AWS specific definition. And you can put those in the same cluster and in the same mechanism, using a similar mechanism we have to like the multiple scheduler support in Kubernetes, use either annotations or the explicit sort of provider config fields to determine which machine controller picks up the machine that you're defining, and sort of mix and match controllers. Does that sound crazy to anybody? We also had a couple conversations with people about API aggregation and what that sort of might look like architecturally. I know internally at Google, when we've talked about the cluster API, there have been some concerns about storing cluster state inside the cluster. Gives you a failure scenario where if the cluster itself is unreachable, you can't figure out what the desired state of the cluster should be to try and fix it, which is reasonable, right? If you're trying to read from the API server to figure out what the API server should look like, and you can't get to the API server, then you're kind of in trouble. And I talked with a couple people about how we can use aggregated APIs to hopefully work around this. And so one of the short-term things that we're looking at doing is prototyping the aggregate API support and verifying that actually will work in the sort of the architectural way that we're imagining. So I don't know if anybody on the call has used the aggregated APIs at all, has experience. I know that the Istio folks are starting to use them. I don't know if anybody else is starting to use them for anything real yet. Let's see.
I believe that like the service catalog in Kubernetes, the Kubernetes incubator service catalog uses aggregate API. I have some experience using that as well. And I'm at Red Hat, and we're working on a similar type of product to do installation, and we're kind of here to see what is going on right now with this working group and make sure that we can contribute to that and that we're together moving in the same direction. And with our product that we have very early on right now, we're using the aggregated API for that.
And do you have any feedback from that experience? Does it seem like it's working well? Are there any unexpected roadblocks that you guys have hit?
I have not hit any roadblocks with it yet. I think, like I said, service catalog is doing it, and it's pretty solid for them. And I've borrowed a lot of their knowledge and experience with it there to bring it over to the product we're working on.
Interesting. Is the stuff, I know Istio, when they run their own API server, it's running inside the same cluster. Is that the same pattern with service catalog and the stuff that you guys are working on?
For service catalog, that is the pattern. It runs in the same cluster. I think that for what we're working on now, I think the plan is to have it in an external cluster because we want to be able to manage multiple clusters with the same installer.
Yes. Okay, interesting. Yeah, because I've been told that you can use aggregate API server to point to API servers sort of outside the cluster, and we could use that for resiliency. Where if the API server hosting your jobs goes down because someone DOSed your cluster by creating a job that is crash looping, you'd still be able to know what the cluster should look like.
Yeah, that's an interesting concept. I guess technically, from a technological standpoint, that seems like it should be possible to do. I don't have any experience doing that.
Cool. All right. Oh, one other thing that I talked about with Chris Love at Kubecon was MachineSets. So I think what we presented so far has been the machine definition. Now I think I believe we presented sort of the roadmap of expecting to build machine sets and then machine deployments on top of machines. Maybe that hasn't been clear enough, but I think it's hopefully obvious to people that sets is the next thing that comes after individuals. And one thing that we talked about was leveraging the cloud, existing sort of cloud implementations of groups. So ASGs on Amazon or MIGs on Google's cloud. And Chris expressed a strong preference for reusing those existing pieces because he thinks that's what users will expect when you have a group of things, to use the underlying grouping mechanisms of the cloud versus sort of rebuilding those client side in our own controller. So I'm curious what other people's thoughts are about that.
Yeah, from again here, us at Red Hat and what we're looking to do, we marry up with that well as well, where we want machine sets, or what we're calling kind of node groups at this point, to mirror, auto scaling groups on AWS and the same type of things that are provided in the cloud. Our thought there is that you would generate this machine set, and then the machines would be realized in the cloud provider, and then our product or the controllers would actually go and discover those machines at that point, and maybe not create the machine resources in the API at that point.
Does it matter at the level where the cluster API sits? Does it matter whether the cluster API makes a decision about this? Can't it just be up to the implementation to decide? Because, like, for example, Azure is going to need to do both.
Yeah, no, I think this is part of the machine controller that we'd write, right? But I do think there is some advantage of having some consistent patterns.
Sure.
Where we say, like, if you have an AWS machine controller and that's using ASGs, and you build a GCP machine controller, like, it would be nice from sort of a user consistency point of view if that one used MIGs, right? So that users that are transitioning between clouds have sort of a similar experience, right? It won't be exactly the same, but it'll be similar.
I totally agree. Something prescriptive makes absolute sense. Yeah.
Can you elaborate a little bit on the Azure part? You said it would need to do both.
So Azure today doesn't support VM scale sets due to some limitations in the VM scale set APIs. And so all of their clusters are deployed with loose VMs that are not grouped together in any way, other than them being, homogeneous within their own associated groups. They are switching to VM scale sets as they are expanding the APIs as needed. And so sometime early next year, they're going to start, running clusters with VM scale sets instead. And so if they were going to hop on this, depending on when they did, they might end up with feet in both worlds and need to support both.
Interesting. Yeah, I mean, I think we'll always want, I guess, or at least it's my desire to always still be able to support individual machines that aren't part of a set that would still be those sort of loose VMs. Because that's one thing that we can't do in GKE, and I've always found that to be frustrating.
Okay.
In GKE, you're forced to have groups. And if you just want one of something, you still have to make a group of size 1, which seems a little bit silly.
Yeah, I see.
So I think we will want to mix and match. But if you are expressing through the API your intent for a group of things, then it does make sense. I think as long as the cloud supports it, to use the underlying group APIs.
Yep, makes sense.
Is there anything written down around thinking about machine sets versus machines? Maybe in terms of, is there any kind of update cycles that we have to be worrying about, or pulling out machines and whatnot?
Can you elaborate a little bit on update cycles? So if just to set the context, if you think about the analogy between pod, replica set deployment and machine set, machine deployment, we've been thinking that machine deployment would actually be like the third level, is the API object where you would express sort of sophisticated rollout policies. And machine sets would be more of a level where you're really expressing a group of things that come from the same template. But the actual sort of strategy of updating those might still be out of scope.
I see. Does that mean that machine set would effectively be exposing ways to, update certain machines individually, such that the deployment can control the rollout?
I think it's a little bit TBD. Like if you look at like the deployments right now in Kubernetes, the deployment itself has like the rollout policy. So we'll have the max in flight, the max surge, et cetera, type parameters.
Yep.
And so if you think about like a machine deployment might say, okay, when you're updating the machine set that's owned by the machine deployments, this is how many machines you update in parallel. This is how many extra machines I should add during the update to make sure I have enough capacity as I'm dropping machines that pods can be rescheduled.
It becomes kind of interesting, right? Because most of the clouds, they typically have quite different configurations for this kind of a grouping of machines, right? And auto scaling groups on AWS or GCP's, managed groups and whatnot.
Right, and that's actually, it's interesting because that goes back to my previous question. If we decided not to use those cloud grouping APIs, right? If we said we're not going to use ASGs, we're just going to create bare VMs on Amazon and tie them together because they all run the kubelet point at the same API server, you could actually implement like exactly the same update strategies in a machine deployment across all cloud environments because you'd be dealing with bare VMs. If we go with the grouping APIs, which I think at the machine set level seems to make more sense to people in terms of mapping those machine sets onto clouds, then that makes the machine deployments trickier because then, like you said, how do you express that you want to do a surge update if maybe ASGs support that but MIGs don't, right? How do we put that into the API and or implement that? And I think the machine controllers generally can probably be smart enough to do it.
I see.
I mean, Sebastian here from Lutze. Our intention was exactly to say, hey, we put all the logic into the node set, or call it now machine set, and don't handle with all the cloud provider specific implementation, because then, like on the cloud provider, it's every time only spinning up a VM, getting the kubelet running, and that's it. And otherwise, you have every time different implementation. And I mean, it really depends, but we should definitely have this possibility to use this, because I think that makes a lot of things much easier, especially if you want to migrate from one cloud provider and want to also generate or build a generic machine controller which can spin up. And I don't see much benefit to map this. Of course, for the user, it would be a little bit more easier to understand. Okay, this is mapping one-to-one. But from the technical side, because like Kubernetes should know most is the best when to scale it up and scale it down. I don't see much benefits of mapping this. In my opinion, it creates only additional complexity.
So you're talking about mapping to like a MIG or an ASG?
Yeah, exactly. So like mapping only the machines to VMs instead of mapping machine sets to instance groups or things like this. Because what's the benefit out of it when you have this mapping? There's not much benefit, or?
Yeah, I would definitely agree with with not necessarily coupling to the IaaS. I'm not sure if there is any particular use cases that someone may have to do so. Yeah.
I mean, on the other side, you could still build a machine set controller, which then do the mapping if you have specific requirements. But in general, I think it makes more sense to, in general, say, hey, we're mainly looking into how we do it with how we map machines with a node controller to the cloud provider.
All right. I'm fairly new to this group. Have you guys discussed already what kind of injection of metadata that you would have to do into the VM to, I don't know, prove identity or something like that?
We've not discussed that specifically. I think that's a broader problem than just a cluster API. There's a couple of proposals, I think, floating around SIG auth for how to do better per node identity and restrict node permissions within the cluster. And I think, as right now, I'm not sure there's anything we could inject that would allow us to do a better job if the core of Kubernetes doesn't support the facilities to leverage that. I think we're at this point waiting for them to. I think Mike Denise has a proposal to restrict what like the node access tokens can do in a cluster. I thought there was another proposal floating around for using like machine identity to prove that nodes were who they said they were.
Yeah, one interesting thing is that if if IaaS semantics are used for the grouping of the VMs, right? It's a lot harder to actually identify or set some VM specific properties, right? So that's definitely an aspect to worry about there.
Yeah, I guess I'm wondering so I mean, generally most of the VMs you're going to say something like, make sure Docker's installed, start a kubelet, join this cluster, use TLS bootstrapping. Here's, a bootstrap token, or maybe you can use like a VM assertion to prove that you should be allowed to join the cluster. I'm not sure how it would be different specifying that in an ASG versus on a bare VM though.
And I guess the question would be is if, for example, the tokens are unique per the VM, right? Or are they, are they the same for everyone? Things like that, right?
Yeah, so right now the bootstrap token is the same for everyone, and then the VMs get per VM identity through the TLS bootstrapping process. There has been some talk about using like the VM attestation APIs on cloud providers to do individual identity on that initial bootstrapping part as well, but I don't think that's been implemented for any clouds yet. And if you did that, I think it would actually be okay if you were in an ASG, because the code you ran to get that assertion would be exactly the same on all of the VMs in the ASG. But what's different is what you'd get back from the cloud provider's metadata server would be unique per VM. So I think even in that case, you could have the same template for all the VMs you're stamping out, and they would just all prove their own unique identities.
That's fair.
Okay, so other things that we talked about was sort of a roadmap of what's next. So for a lot of this, sorry, I'm moving around. For a lot of this development cycle, we've been sort of focusing on getting an initial sort of prototype implementation. Chris has been working on getting a prototype one built on AWS as part of Kubecon. And we've been trying to sort of use that to drive some of the API discussion. So I think, in my opinion, what's next is to sort of try to get some consensus on at least the initial alpha versions of the API and get those sort of finished, if you will. I know we have versions checked in right now that we're building code against, but the 2 PRs for those are still outstanding. So I would love to see that get merged within the next couple of weeks before the end of the year. And then we can have subsequent PRs that go out to mutate the API, but at least get the initial versions checked in. I think that the rate of comments on those has gone down pretty drastically over the last couple of weeks.
Are the sets, machine sets, considered a candidate for alpha, or is that something that's been planned for sort of later?
Well, I imagine we'll stay in alpha for a little bit longer, and I would like to see machine sets show up while we're still in that phase, because that will help us sort of prove out the underlying API and that it makes sense. Both Chris Love and Justin were really interested in starting to build some prototype support for machine sets in COPS. As they said that COPS would love to adopt the machines API, but sort of not without machine sets. That was kind of where they needed it to be before they could adopt it, and so they were both very interested in getting that part implemented.
Okay, we could I'd probably throw our name in that bucket as well. That's something that we're looking at pretty hard. That would be maybe we can look at that.
Yeah, I mean, conceptually, a machine set should be pretty simple once you know what a machine looks like, right? Like a replica set is, you take all the fields from a pod, you call it a template, and you add a count.
I mean, do you want to have a look at our node set? Because there's already, it creates nodes, but probably we can use this as a starting point. And we have there is already a node set controller, which then generates nodes out of it. I think it would be not a big task to change this to machines. And then we already have probably in a week or so a running prototype where we can start discussing what to enhance or what must be changed.
Yeah, I mean, I think what sort of makes sense is to sort of figure out how we can combine efforts, right? I feel like you know, I probably ran into like 6 different people at KubeCon that seemed like they were doing the same thing in this space, and trying to sort of pull that together under a common umbrella, and make sure that we're driving in the same direction is really important at this point. So yeah, Sebastian, if you guys want to you know, send a pull request with the API for that over to the Kube deploy repo, that would be awesome.
Yeah, okay.
The discussion there.
I will talk to Henrik, and probably this or latest beginning of next week, probably we can do a first PR.
Awesome. I guess that reminds me of another thing we talked about at KubeCon, which is at this time for meeting is pretty terrible for you guys, and folks in Europe in general, I think. And again, I know you managed to make it today, but if we should be rescheduling this meeting to be at a earlier time during the day.
Yeah, if you probably, currently I'm still in the US. I'm in San Francisco, so today it's fine. But if you could probably move it when it's fine for everyone, move it 1 hour earlier would be definitely help us to get more people from our side involved.
All right. Does anyone on the call have objections to moving an hour earlier? I'm seeing lots of heads shaking sideways, which is good. I'll send out a note to the SIG mailing list, making sure that nobody objects that is actually interested in showing up, because people can object all they want if they're not going to be here. I don't really care. And then we'll plan to do that for our next meeting. Speaking of which, at the meeting this morning, we talked about sort of plans for the rest of the year, since I know a lot of people are going on vacation. We decided to cancel the 9 a.m. meeting for both next week and the following week. Are enough people in this meeting going to be around next week that we'll have consensus to hold a meeting, or should we cancel? Craig was a thumbs up. I'm not sure if that's a thumbs up for being here or canceling.
I can join next week.
Okay. If we move it an hour earlier, Sebastian, can you join next week?
Yeah, I can join.
Okay. Devin, sorry, I interrupted you.
Oh, sorry. I was just going to say, yeah, I can make it next week as well.
Okay. I'm hearing enough people that I think we should probably plan on having this meeting next week. We'll tentatively plan to have that 1 hour earlier at 10 a.m. Pacific. And my guess is we'll want to cancel the meeting the following week. So I'm not sure if anybody's going to want to be around that week. But we can discuss that next week, since we'll have a meeting next week. All right. Okay. Other agenda items that people want to talk about. Everyone is very quiet today.
What needs attention? How do we get folks involved? That's the common theme for SIG cluster lifecycle, right?
Yeah, that's a great question. So as I mentioned earlier, I think if we can get some review from people who care on the 2 PRs that are outstanding and try to get those merged, that would be really great. It'd be nice if we could have those merged by next week, and also have a PR from Heinrich on the MachineSets by next week. And if people could take a look at that. So I think that coming to an agreement on the API definition is important to unblock people from working in parallel on the controllers. I will poke Chris and check on status on the Kubecon side. I know she's nominally on vacation for the rest of the calendar year, so we may not see a lot of progress there. We'll have to see if someone else is picking that up. And then I think from the Google side, what we're looking at doing next is working on what it would look like to move from using CRDs to using API aggregation for the implementation of the objects. So the Kubecon demo was driven based on CRDs, but I think that, you know, we've discussed in this meeting before that people believe that the long-term architecture should be API aggregation. So we're starting to transition to that.
Does anyone have a fresh enough memory to cover the benefits to that approach for the API aggregation?
Chris, I see that you're on the call. Do you want to take an initial stab at that?
question the benefits of API aggregation.
Yeah, versus the CRD approach.
Proper versioning, so you can convert between V1 alpha, V1 beta, and actual GA. So you have conversion built into the type system, you have defaulting, you have validation, you can do special handling on the handlers in the API server if you want. It brings all sorts of benefits.
Okay, thank you.
Also scaling status. They'll come in CRDs, but the pull request is still not merged.
And I would add that CRDs seem to be sort of a dead end. If you put data into CRDs, you can't merge them in, you can't move them to API machinery data currently.
You broke up about halfway through. You said if you put data in, you can't do what?
You can't like migrate it into a real API machinery type later. It doesn't. No, you'd have to like dump it to YAML and put it back in, which is.
I think the other big advantage, especially for the cluster API, is that with API aggregation, I believe you can put the API server for your resources outside of the cluster. So this is one sort of unique thing we've talked about with the cluster API is that we might want to have the controllers and maybe even the backing API server not running in the same cluster that's being managed for resiliency. And you definitely can't do that with CRDs since they live in the main API server.
Okay.
And also to give the possibility, I think maybe it has shared with the API server for the lot of different clusters. Otherwise, using CRD has to be one cluster. You have one controller running in the cluster.
You're really hard to hear also, just like Justin. Can you try to speak up a little bit? Say it again.
Oh, I mean, for the CRD, you basically, each individual cluster, you have to have its own like the controller running inside the cluster. With aggregate API server, there's possibility to have a shared like implementation or shared instance of aggregate API server for a lot of different clusters.
Yeah, and so I think if you're implementing this like what the Lutzi guys are doing, or what we might look at doing on GKE, that becomes advantageous, right, for sharing resources across clusters.
Yes.
So I don't see very many downsides of using API aggregation versus CRDs, except for the fact that you have to run your own API server, which has been done already by the Istio folks and the service catalog folks. And so I don't think, other than the extra resource usage, that there's too many risks of doing it that way. All right, I didn't have too many other things to talk about today. I'm still kind of recovering from being sick after Kubecon. Is there anything else people want to talk about, or should we call it early today?
So right now, in the current implementation of the replica sets and the deployments, that's in the core API. I mean, what of the logic there can be applied to what we are doing? So I think it's too early, but are there any plans to make the logic more generic so it can be used by full XY deployments and then full XY sets and etc.? Because I think that there is a lot of common logic there, especially for the rolling update, housing, and etc.
So I don't think we've written any logic yet for things like rolling updates, because I do imagine that would be one of the higher level controllers, right? So if you tell a machine to update, it should update right away. And if you tell all your machines to update at exactly the same time, they should all update right away at exactly the same time, because that's what you've told them to do. And if you want to do a rolling update, then the higher level controller should tell each machine to update at the right time. The updater that we pulled together for the demo does the former, where it just tells every machine at exactly the same time to update. And that was to make the demo go fast, but it actually also shows a potentially valid use case where maybe you do want to actually update everything at sort of max parallelism, right? So we don't actually have any rolling updates yet. I could imagine that the client-side updater that we built would be pretty easy to mutate to, instead of update everything as fast as possible, to update one, wait for it to show up, update the next, wait for it to show up. And that's basically what would be implemented during the MachineSets upgrade as well, except that would be server-side. Just like we have in kubectl, we had client-side rolling update, and then we moved that into the server. Although in that case, it was for the higher level objects, right? It was rolling update of replica sets became server-side in deployments. So we again have to decide what sort of update support we put into sets versus putting it at a higher level than sets, and keeping client-side until we have the higher level.
What was actually referring to was the fact that the logic and the way the deployments and okay, let's put it to deployments because it's easier. The deployments in almost all the cases, they are expected to behave in a similar way. So when you're doing a deployment of pods and then on machine, they should more or less behave exactly the same way. And my idea was eventually to influence the core API to more or less externalize the core logic there for the actual doing the deployment. So we can just reuse it for our own object, not to re-implement everything there. This was my proposal, more or less.
Yeah, I think that makes sense. I guess in my mind, what I sort of envision is there's going to be a bunch of cloud-specific code, but a lot of like the sort of those core logic loops are going to be very similar, or hopefully exactly the same, across many of the implementations. So in addition to having like, here's the API that everybody's using and that you can import into your project if you want to build your own code, we should have some standard libraries that you can import also that have those control loops. And then you can glue those on top of your cloud-specific code that you have.
I'm going to ask a clarifying question here, maybe. Is the current proposal, or is the current thinking around machine sets that there will be a controller that manifests the machine sets as machine objects in the cluster first, and then those would be instantiated in the cloud? Or is the machine set going to be the only representation of the machine set, and then the controller directly acts upon that object itself? I'm wondering if that's where the question was coming in about replica sets and pods and deployments, because I can kind of think of them similarly as well, but I don't know if that's actually what the cluster API is trying to have them be expressed as.
I'm happy to put my opinion down, but if someone else wants to put their opinion first, that would be great.
I can only speak to what we're very new at this, but what we were planning was that the concept of the machine set would create the scale group or whatever in AWS or GCP, and then whether or not that actually resulted in a machine record or not was still kind of open on our end. We weren't sure if we're going to need that or if we can just treat them as a completely just as a group that may be thrown away or replaced at some point.
I know that we're very strongly taking the opinion that machines, your nodes, are not special snowflakes that you need to hang on to and love and care and individually update one of them and treat them as, the most amazing thing in the world. So our thinking, which as you guys can tell, we're just starting to show up here and be a pain, is very strongly based on the idea of a set or a group or things like that. Our plan was, or our thinking is all about taking advantage of the AWS scale groups or the GCE or GCP MIG, so that we would never, a human would never come in and say, create 17 nodes. We would say create a scale group with 17, and 17 nodes would get created. And those nodes may be represented in the API server. We may actually be able to operate on those nodes in the API after they're generated, but from our point of view, the thing
Oh
that
yes, yes.
we would interact with would be the group.
I don't disagree with anything you said. I think people probably take a similar thought towards deployments in Kubernetes, though, and yet they still end up getting their
Okay, maybe I forgot.
99% of the time I never touch the pod, but it's interesting and sometimes useful that it's there. You know, if I wanted to go tweak a Docker version on a machine, or something like that for a quick test case. Anyway, not necessarily that I'm advocating for this, just a thought.
Yeah, it is also an interesting analogy and something that I think I've heard discussed here, which would be you can't change a pod, right? You can't go into a pod after it's running and change the image. You can't go into a pod after it's running and, although maybe a vertical pod autoscaler one day will allow such a thing. But today you can't really go in and do anything meaningful with a pod. And so some of the thought that I feel like I've seen trying to go back and read notes of discussions in this group lead me to believe that we think machines are going to be these mutable pieces of the infrastructure, which is obviously a very traditional way to look at machines, but is not necessarily the path that I'm excited about.
Right.
Trying to deal with things at scale.
Yep, I agree.
Yeah, I think what we've expressed in the past is machines can be mutable, but there are also a lot of people that are really excited about immutable infrastructure and saying, I don't want to mutate my machines. I want to just throw them away and create replacements. But there are use cases, especially if you think about on-prem, where that's maybe not an option, and you want to be able to say, I have a physical machine. Unlike a VM, I can't just throw it away and come up with a replacement. Maybe you can sort of throw it away in the case that you re-image and re-pixie boot it to come up with a replacement, but it's still sort of the same underlying physical machine.
Yeah, no, I think it's reasonable. I think even if MachineSets never, they don't act like replica sets and don't instantiate machine objects, I think that's fine. I think if you have people that want to mutate individual machine objects, they can write their own tooling and write a bash script that spits out 20 identical machine objects, and then if they want to mutate them, they have the flexibility to do so. Anyway.
The question of how to deal with on-premise is obviously an extremely difficult one, where the idea of scale groups don't exist in most people's local data centers. In that situation, in my mind, it does seem very interesting or something, I'm not quite sure what the right word is, to have a machine API object where you can represent some form of status. And it could mean that if you want to upgrade the machine, your status you have to run something that destroys all the stuff that's already there, and then that machine could be placed into another group. I'm not quite sure how to handle the on-prem, but deprovisioning a machine without having to rely on your data center having, re-imaging ability is definitely an interesting problem, and the one that leads me to believe that maybe a machine API object should at least exist, even if I don't see a machine.
I'm gonna go grab a sandwich.
The center of mutability.
I'm kind of gonna go against the grain here, and I had the vision that MachineSets would just stamp out individual machines, and that way any provider that had a machine controller that could create a machine from a machine definition could have a generic like machine set controller that just stamped out these individual machines, and it would work, and that there would always just be the individual machine. Now, whether that machine is like immutable or not, that's still up for debate, but I never envisioned MachineSet directly targeting a cloud scaler, but in and of itself kind of being its own scaler.
Yeah,
It worked on all clouds.
Yeah,
I'm very AWS first, but I would also agree with Chris in that, like, even on AWS where you have auto-scaling groups, like, I still see value in nodes, or for nodes, for non-masters, in not using an auto-scaling group necessarily, but having a machine set, at least optionally, be able to generate machines and then call AWS run instances rather than creating an auto-scaling group. The reason being that then you have more control over, you don't have to have the same instance type in each one, for example. I'm not saying that we want to do that, but you have a lot more control over directing, which ones spin up, all these sort of things, which you
That
don't.
doesn't actually, if you wanted a snowflake, you could have a scale group of size 1. And if you wanted some large instances and some small instances, you're going to end up with, in my mind, 2 different scale groups, like in the same cluster. I'm not saying that you only get one scale group for the whole cluster and your whole cluster shall be homogeneous, but the idea that nodes as an individual thing should be the core of our thinking, I'm concerned by.
It's not so much that I need snowflakes, it's just that I need to be able to take the same tools everywhere I go. And if I start having machine sets target individual cloud scalars, then maybe I have my own auto scaler that targets machine sets. It doesn't quite work anymore because of the way it interacts. Whereas if the machine set just pounded out machine templates and the machine controller just created those VMs, I mean, they're not snowflakes. They're still part of a group. It's just that group is now called machine set, and it's not targeted towards like AWS scalars or GCE MIGs or anything like that.
Yeah, so that's a question that I had as someone new to the discussion. If we're using those kind of a magical auto healing properties or scaling kind of behaviors in MIGs or maybe even in AWS, if all of those would be kind of at odds with like what the cluster is actually doing with the like node outscaler and other things that could be acting on them as well.
And also to add
those things.
And also to add to that point, as far as I remember, when you have to delete the node from the autoscaler in AWS, you can't delete a specific node. Like you can say, I want to reduce from 5 to 4, and it will select which node goes wrong, if I remember it correctly.
I think you can in AWS, but you shouldn't assume that every cloud allows you to do that. I think that's a use case which, yes, it's certainly very valid that you want that ability to steer.
One of the other dissonances that Brian Grant pointed out when we originally were talking about this was with pods and replica sets. You can kick a pod out of a replica set without killing it by changing the labels on it. The replica set will create a replacement for you, but leave that one running, and you can use this to quarantine pods without killing them, which is a really cool feature of Kubernetes. And it would be nice if you could do that with machines too, but that's going to probably require changes to MIGs and ASGs on Google and Amazon respectively for that to work.
But the question is, if you really want to integrate with the autoscaler, I mean, when we only mapping like machines to VMs on the cloud provider, then we easily can do this, and you can change this. The machine is still existing, and all of the logic is inside of the Kubernetes cluster.
Yeah, it seems like just from the discussion that there's been quite a few points brought out about how the approach of using the Kubernetes objects and not integrating with the autoscaler allows us to have abstractions that might be superior to the capabilities supported by the cloud provider.
I mean, kind of what I'm hearing is the group thinks we can better write autoscalers than GCP.
We have more information in the Kubernetes API, I think is the distinction I'd make. Like we know our workload better when we.
I mean, on that specific point on GCP, we did decide that a couple of years ago, and we said, please don't use the MIG autoscaler for Kubernetes clusters. We have our own.
I don't think they're exclusive though. Like I think like there's a big debate here that isn't necessarily really a debate. Like I think we should have a generic machine set that stamps out machines that can be used basically anywhere you can run a machine. And then we should have an AWS specific one that maps to an auto-scaling group, maps to Spot Fleet. We have one on GCE that maps to a MIG, and all these things, and we can sort of see and experiment. I don't think we yet know though whether, like if we're mapping to a GCE MIG, what the order of operations is in terms of creating a machine, like whether a machine exists at all, and if it does, when it gets created and by whom, I guess, right?
Yeah, I think that goes back to the earlier part of the discussion about multiple machine controllers in a cluster. Like you could imagine you have a cluster that has 2 machine controllers. One stamps out individual VMs and ignores MIGs, and the other uses MIGs and sort of glues those to machines. And you could try both, right? And see which one makes more sense.
in that model, are we imagining two types of machine set objects then? Like one's machine sets and one is automatic machine sets? Or are we thinking of machine sets that get stamped out and then N different types of additional machine sets that are cloud specific?
I would probably model it the way we did with custom scheduling and just have it be an annotation on the machine set object, like custom machine set controller or something, just for at least for the experimentation phase.
Yeah, I agree with that. I think we want one API object with a way to select who you want back in the implementation of it.
Okay, makes sense.
Yeah, with what Rob is saying, I can hear a clear advantage of being able to use like the Kubernetes agnostic or the cloud agnostic machine set in like say GKE, but then also to have a machine set that's run with a MIG, and then be able to tie that MIG to like a Google Cloud HTTPS load balancer. Right, that would be a really good integration or use case for what that suggestion implies.
Okay, so yes, to sort of summarize that long rambling discussion that we had, we do not yet have consensus on whether we think it is the right thing to do to build on top of the cloud provider abstractions for groups of machines. And we don't want to commit either way at this point. We should build a generic machine set controller that stamps out machine objects, bypasses what the clouds do, and potentially at the same time, because that we'll definitely want to use everywhere. At the same time, we can build ones that do run on top of MIGs and ASGs and scale sets, and see if that makes more sense. I mean, I think with some of the Kubernetes features, we have an API machinery. You can do things like say this machine came from this machine set. And so I think the controller can know how to tie together machine and machine set objects, even if we're using ASGs, and make all of the links work correctly. So I think it's definitely possible to do, but they are going to be more cloud-specific implementations. Does that sound like the right summary to people? And along with that, Heinrich is going to send a pull request to add a machine set object into the cluster API definition, or at least to start the conversation going.
Yeah, I mean, for the node set, we already have like two example implementation with one like where we integrate with the node, which is generating nodes, and the other one is an example implementation which integrated with the GKE, instance groups, so that you can directly start it there. So I think with this, probably we can then start the discussion what ways we allow and what ways we will force or we will not allow.
All right, we have about 5 minutes left. Does anybody have any short conversation topics they want to bring up? I mean, Tim asked earlier sort of tactically how people can get involved. The other thing people can do is if they're interested in trying this stuff out, they can sort of run through the code that we have today and see how it works, see what the rough edges are on GCP. You can start prototyping and hacking together other implementations of the API that run elsewhere and see how that feels and how the API looks. I think that's been our best avenue so far to look at how we might tweak the API, is to try to actually write code against it and see how it works, both on the implementation side and the client side, right? So that was kind of the point of the demo, was implement the API and see if we can get it to work, and write some client-side tools that use the API and see what we can get them to do. So if people are not sure how to sort of best go about deciding whether they like the API and they want to write some code, that'd be a good way to do it.
I've been pointed at multiple repos. Where is the official set of alpha implementations are sitting?
Sure. Yeah, it's in the kube deploy repo right now.
Okay.
We set up a Go link, so go.kdes.io/cluster-API will take you to the right place.
Thank you.
And I had pasted one of the pull requests that we were trying to finalize as well in the group chat.
Thanks.
And Rob, maybe just a quick question to help me understand the architecture. Maybe it's helpful. So this is a controller that implements cluster API in CRD, and you need an existing Kubernetes cluster in order to start using it?
So what we have today is we have a command that will create a cluster, install the CRD, and then launch a machine controller. And then that machine controller will watch the CRD, so that if you add new machines, it will create new VMs.
So it's required to currently, since we are relying on CRDs, to have a cluster to bootstrap.
Yeah, so our bootstrapping that we built for the demo was not to create a cluster, but just create a master. So you create a single VM that's your install, and you run kubadmin init on it, and then you install the CRDs, and you launch the machine controller. And from there, you can instantiate the rest of your cluster that way.
Okay, cool. That's cool.
Yeah, but it should be too hard to have an existing cluster, then use a library to add our stuff.
Yeah, and I think that's what the COPS folks are planning on doing is they're not going to change their cluster creation flow, but once they create a cluster, they can install CRDs and use the machines API to manipulate it. That's my understanding. Justin's giving me a thumbs up, so I think I'm right.
Yeah, I mean that's my guess so far, right?
Yeah.
One last question. How was the Kubecon actually? I couldn't actually attend, so how many people joined the sessions? What about questions and etc.?
Yeah, so the sessions were really short. 35 minutes is not very long. So both the SIG cluster lifecycle, like SIG update, we kind of ran over time with the questions. And the cluster API talk, we ran over time in questions also. There were a lot of hallway conversations afterwards, but all the people that were attending that session didn't get to hear everything that was discussed there, which is a little unfortunate. I think one thing that I learned is we should have done a SIG deep dive where we could all sort of sit around. I think those were much longer. They were like an hour and a half and intended for people to sort of hack on things together. That would have been a really useful forum to just get people together and discuss sort of plans for our SIG, because there was not a great forum either during the contributor summit or during Kubecon itself to sort of have the SIG members get together and talk about what we're working on and where we're headed, whiteboard, design discussion type stuff. A lot of that just sort of happened in the hallway pairwise. But it seemed like overall the sessions were all, the ones I attended were all really well received. So
great, thanks.
All right, with that, we're at time. So I'm gonna go ahead and call it, and I'll see everybody next week. Remember, if you joined late, we're gonna move the meeting an hour earlier, so it's gonna be at 10 a.m. Pacific time instead of 11. I'll also send a note out on the mailing list about that. And I'll see everybody soon.